Something impossible is happening right now. Comet 3, I/ATLAS, has a tail shooting toward the sun, punching through a 400 kilometers per second solar wind that should blast it away. This isn't normal physics. To push material over 1,000,000 kilometers sunward against that apocalyptic force requires densities 1,000,000 times greater than the solar wind itself. Scientists are baffled. Natural comets don't do this. The violence needed is staggering. Billions of tons ejected in focused jets. What's driving this? Let's dive right in. Between November 22nd and 24th, astrophotographers across 3 continents captured something that has the scientific community in heated debate. Using telescopes from Spain to Chile, they documented 3 I/ATLAS in unprecedented detail, and what they found doesn't fit the textbook. The clearest image comes from Mitsunori Tamura using a half-meter telescope. It shows a massive glowing coma and a tail streaming 5 million kilometers away from the sun, exactly what you'd expect from a comet. But then there's the feature that's causing all the controversy. An anti-tail extending over 1,000,000 kilometers, pointing directly at the sun. Here's why this is so profound. The solar wind flows outward from the sun at 400 kilometers per second. That's over 890,000 miles per hour of charged particles blasting outward. This wind pressure is what shapes normal comet tails, pushing them away from the sun like flags in a hurricane. But 3 I/ATLAS is doing the opposite, forcing material sunward through that same devastating force. The physics required are staggering. Scientists calculated that maintaining this anti-tail against such opposition requires ram pressure exceeding the solar wind by factors of 1,000,000. We're talking about mass densities so extreme they shouldn't exist in typical comet behavior. This isn't gentle outgassing. This is violent explosive mass ejection on a scale rarely witnessed. If 3 I/ATLAS is a natural comet made of ice and rock, the implications shake our understanding. Current calculations suggest it's losing billions of tons of material, potentially over 10% of its total mass, in just 2 months. Even the most active comets we've studied don't shed mass at this ferocious rate. Something about this visitor is fundamentally different from anything in our solar system. What's more unsettling is the acceleration problem. New measurements confirmed what some researchers suspected but hoped wasn't true. 3 I/ATLAS is exhibiting non-gravitational acceleration at 10 standard deviations. In scientific terms, that's statistically certain. Not measurement error, not data noise. The object is actively changing its trajectory through space. And it's not because of the sun's gravity or planetary influence. For a natural comet, this requires asymmetric jets of gas and dust shooting out unevenly, acting like tiny rocket engines. But the amount of mass loss needed to produce this level of acceleration doesn't align perfectly with standard comet models. Some researchers have quietly noted that if this were an artificial object with technological propulsion, far less mass would be required to achieve identical effects. Chemical thrusters or ion drives could produce the same acceleration while expelling significantly less material. The overwhelming majority of astronomers believe natural explanations exist. But the fact that these questions are even being discussed in research circles tells you how unusual 3 I/ATLAS truly is. The trajectory adds another layer to the mystery. According to new calculations, 3 I/ATLAS isn't just passing through. It's heading for an encounter with Jupiter that could fundamentally alter its path. On March 16th, 2026, the comet will reach Jupiter's Hill radius, where the giant planet's gravity becomes dominant. This kind of planetary interaction has never been observed with an interstellar object before. Here's the detail raising eyebrows. Scientists can predict this Jupiter approach to better than 4 significant digits of precision. An object that traveled through interstellar space for potentially millions of years, experiencing gravitational perturbations from passing stars and cosmic debris, arrives with a trajectory precise enough to target Jupiter's gravitational sphere with extraordinary accuracy. Coincidence? Maybe. But it's the kind of coincidence that makes scientists uncomfortable. NASA's Juno spacecraft, currently orbiting Jupiter, could witness this gravitational dance firsthand. Any unexpected course corrections during that encounter could reveal crucial information about what's really happening with this object. We don't have to wait until March for answers, though. The critical moment comes much sooner. On December 19th, less than a month from now, 3I/ATLAS makes its closest approach to Earth at 269 million kilometers. The Hubble Space Telescope and James Webb Space Telescope are both being positioned for this opportunity. After December, 3I/ATLAS speeds away forever, and we may never get another chance. What scientists are looking for could solve this mystery. Spectroscopic analysis will identify the exact chemical composition of those jets. If it's standard water vapor and common volatiles, that supports the natural comet hypothesis. If they detect unusual compounds or emission patterns that don't match sublimation models, we're in uncharted territory. Jet velocity measurements are equally critical. Natural sublimation produces gas moving at a few hundred meters per second. Chemical thrusters produce faster exhaust velocities. Ion drives would be faster still. By measuring the exact speed of material in those jets, scientists can narrow down the mechanisms at work. Most importantly, we need to see the nucleus itself. Despite all these observations, we still haven't gotten a clear look at the solid body at the center. The coma is too bright, obscuring everything beneath. During the December flyby, our most advanced telescopes might finally peer through that glowing envelope and reveal what lies at the heart of this mystery. The brightness curve is already making scientists uncomfortable. Standard models predicted certain luminosity based on distance and size, but 3I/ATLAS has been consistently outperforming those predictions. Research from the Lowell Observatory found the brightness increasing at a rate nearly double what normal comets show. This object is either made of super volatile ices that explosively boil off as it approaches the sun, or something else is at play. What's particularly striking is the consistency of its behavior. Most comets tumble unpredictably, causing jets to spray in different directions with variable brightness. But those jets from 3I/ATLAS remain tightly focused and sustained. That kind of consistency suggests either an extremely uniform composition being heated evenly, or organized processes rather than random outgassing. The European Space Agency's Trace Gas Orbiter provided crucial data in October when 3I/ATLAS passed Mars, improving trajectory predictions by a factor of 10. That precision is what allows confident predictions about the Jupiter encounter months in advance. This international cooperation, observatories across continents, spacecraft positioned throughout the solar system, represents our best effort to understand something truly unprecedented. Here's the reality we're facing. Our models are based on 3 confirmed interstellar visitors. Oumuamua had strange acceleration. Borisov looked more conventional. Now 3I/ATLAS with its explosive behavior and focused jets. Every interstellar object we discover is completely different from the last. Either we're witnessing incredible diversity in interstellar space, or we're missing something fundamental about these visitors. The December observations will force us to confront these questions directly. Right now, 3I/ATLAS is racing toward that rendezvous. Astronomers are finalizing schedules, calibrating instruments, preparing for the most intensive study of an interstellar object ever conducted. Whatever emerges in the coming weeks will fundamentally expand our understanding of what exists beyond our solar system and what's truly possible in this universe. This is science unfolding in real time, and December will give us answers. When Hubble and James Webb turn their instruments on 3I/ATLAS, we'll finally know if this violent behavior comes from exotic interstellar ice, or if we're witnessing something that rewrites the rules entirely. Here's what we know for certain. An object is shooting material toward the sun against a 400 kilometers per second wind. The physics required are extreme. The acceleration is real. And in less than a month, we get our only chance to understand what's really happening before it disappears forever. So, what's your take? Is this the most exotic natural comet we've ever seen? Or are we missing something bigger? Drop your thoughts in the comments below. I read every single one, and this is exactly the kind of mystery worth debating. If this breakdown gave you value, hit that like button right now. Subscribe to Galactic Breaking News and turn on notifications so you don't miss the December updates when the data drops. This story is far from over, and we'll be covering every development as it happens. Share this with someone who needs to know what's happening in our solar system right now. We're witnessing something unprecedented, and you're part of the community tracking it together. Thanks for watching, and I'll see you in the next one.